Graphs of rational functions. A good comprehensive graph of a rational function exhibits these features. It shows all the x and y intercepts. It shows all the asymptotes, vertical, horizontal, and or an oblique asymptote. The point at which the graph intersects its non-vertical asymptote, if there is such a point, and the behavior of the function in each domain interval determined by the vertical asymptotes and the x-intercept. So we want something in each domain interval determined by the vertical asymptotes and the x-intercepts. The steps for graphing a rational function. We want our function to be the numerator and denominator are polynomials. The expression is in lowest terms. Step 1 is to find any vertical asymptotes. Step 2 is to check for symmetry. Step 3 is to find horizontal or oblique asymptotes. Step 4 is to find the y-intercepts by evaluating f of 0. Step 5 is to find the x-intercepts, if any, by solving for f of x, having my f of x equals 0. These really end up being zeros of the numerator. Step 6 is determine whether the graph will intersect its non-vertical asymptote. The asymptote is either y equals a number or y equals mx plus b. It's a slanted line. We solve then, to do that, we solve f of x equals that b or f of x equals mx plus b, whichever it is. Then we need to find selected points as necessary. We're choosing an x value in each domain interval determined by the vertical asymptotes and the x-intercepts. And step 8 is to complete the sketch. So let's actually start doing that with one graph. Step 1 is to find the vertical asymptotes. So a vertical asymptote is what will make the denominator equal 0. So x plus 1 equals 0. X equals negative 1 is my vertical asymptote. So I'm just going to go ahead and draw that in. So there's my vertical asymptote. Step 2 is to check for symmetry. So with my symmetry check, when I'm checking for symmetry, I'll find f of negative x. Well, that turns out to be negative 4x minus 2 over negative x plus 1. That does not equal either f of x or negative f of x. So for symmetry, there's none that we recognize this way. Next, we need to find the horizontal asymptote. We find the horizontal asymptote by looking at if they are different, if the degrees are different, if the bigger one is on the denominator, the higher degree is on the denominator, then it's y equals 0. Or if the higher degree is the numerator, you have to divide. But since these are the same degree, we go by the ratio of the leading coefficients. And here the leading coefficient would be 1. So we end up with y equals 4. And we can go ahead and draw in that asymptote also. So there's my horizontal asymptote. Now we want to check and we want to do the y-intercept. So the y-intercept is where x is 0. So we'll fill in a 0 here. That would give us 0 minus 2 over 0 plus 1. So the y-intercept will be negative 2. So 0, plot the point, 0, negative 2. And then we want to find the x-intercept, and the x-intercept is where y equals 0. we solve that, we find out that the 0, the only way this fraction equals 0 is if the numerator equals 0. So 4x minus 2 equals 0. That means x will equal 1/2. X will equal 1/2. So we have this point right here. Okay. Then we need to ask the question, does it intersect? The question is, does it intersect the horizontal asymptote? And to find that answer out, what we're going to do is set the expression equal to the horizontal asymptote, which is 4. So we're going to have 4 equals 4x minus 2 over x plus 1. When I cross multiply, I'll have 4x plus 4 equals 4x minus 2. When I go to solve that and subtract 4x from each side, I'll have 4 equals negative 2. Well, the answer to that is no. So the answer, does it intersect the horizontal asymptote, is no. My next step is to find selected points. Now, my selected points I need, if I start tracing along the x-axis from the left, the first thing I run into is this vertical asymptote. So I need some point between negative infinity and the vertical asymptote at -1. So let's say I pick 2. And I fill in, or I pick -2, sorry, get it there. I fill in -2 in the expression. I'll have -8 minus 2, so that's -10, over -2 plus 1, that's -1. I end up with -2, 10. And that point would be right here. That tells me that this graph is between here. These are asymptotes, so they do not cross. We already found out that it didn't cross the horizontal asymptote, never crosses a vertical asymptote. And so we can just kind of sketch this in and say, okay, it's going to be there curved, it's going to come close to that one, it's going to end up coming close here. And we've got that drawn in. Now we need to check, as we're going along the x-axis, between -1 and 1/2. We need a point. Well, we already have between -1 and 1/2. In that domain section, we already have the y-intercept at 0, -2. So we've already got that point. We didn't have to do more work. Now we need a point between 1/2 and infinity. So we're looking for a point somewhere from 1/2 to infinity. And let's say we choose to use 3. I'll just pick 3. So that will give me 12 minus 2, so 10 over 3, or fourths. So that ends up being 2.5. So 3, 2.5 will be here. Now we can plot, we can draw, we've got 3 points over here between these asymptotes. So we can draw them. It's an asymptote, so it comes close, but does not cross. So this is our completed graph.